Welcome to Triangle Similarity Postulate. We're going to do one more problem together. So this is kind of part 2 of this lesson. So we want to figure out if the triangles are similar first, and then we'll solve for our missing sides. So if we look at our figure there, we're given that angle T, usually takes me 3 times, there we go, for it to write the very first time I start recording. So angle T is congruent to angle C. That is a given. Right? And now we have something else that we know. If we were to separate these triangles out, right? So here is the smaller triangle. I can just kind of put him right here. It's always a good idea anyway to separate out overlapping triangles so you can label them. This is 6, and that is all we kind of know something else. This is x, so the whole thing is 12, right? This whole side is 12 from here to here. If I subtract the x, if I subtract out this part here, come on, that part there, right? I'm going to have what's left over. I'm going to have the side of the triangle there, which is BU, and that is 12 minus x. I may as well label that. All right, so that piece is 12 minus the other piece, minus x. So I thought maybe I'd label the triangle since I have to draw it out anyway. Now, but if you notice, we have the larger triangle, triangle STU, STU, if you will, and the smaller triangle, BUC. He's not but, he's just buck. All right, and if you notice, they have something in common. Right here and here. I'm going to put 2 arcs because they're probably not the same as these angles right there. So we're given angle T is congruent to angle C, and we can call that angle U. Sorry, the B is kind of in the way there. I'll just put it over here. So angle U is congruent to angle U. There's only one angle there at U, so we can call it angle BUC and angle SUT, but we can just call it U, right? And that makes it clear that that is the exact same angle, because there's only one angle there anyway. So angle U is congruent to angle U. That is the reflexive property. We have 2 angles in one triangle, congruent to 2 angles in another triangle. For triangle STU is similar to triangle BCU. I have to make sure I match up the corresponding parts, and that would be angle, angle, triangle. I'm going to put a triangle symbol there because I don't have too much space. Similarity, I'll abbreviate, postulate. I'm already over the triangle. So since the triangles are similar, we can solve using proportions. Right? It says we weren't really told here the triangles were similar, so we have to determine that out. If you're told the triangles are similar, and sometimes you'll have to be told because you won't be given enough pieces to know, then you can just start solving. So since the triangles are similar, we can solve using proportions. I need to include the side with the x because that's what we're solving for. We're solving for x, that little missing segment there. All right, and we got to be careful. We only use sides in the triangles, however. All right. X is not a side in a triangle. It's just a little segment there. Actually, it's a little piece of a trapezoid. You see the little trapezoid, trapezoid SBCT. It's a little piece of that. However, we do have the x included in the side BU. Right? So even though we're not solving for that side, really, we're solving for x, we can use side BU because BU is the whole thing, 12, minus that little segment, minus the x. And it includes the x, so let's use that segment. So triangle BCU, I'm going to put in the numerator, and I'm going to put the other triangle, triangle STU, in the denominator. Right? And since I'm solving for x, I want BU to be in the numerator. BU corresponds with SU in the other triangle. Okay? And I need another side in the triangle. Right? And actually, let's label the other side. We have the other side labeled in the smaller triangle. Let's label it in the bigger side, in the bigger triangle. Because if we use 6, we'll be wrong. If we use 18, we'll be wrong. But if we use 24, we'll be right, because that side length there is 24. All right, and so I need to stick with BCU in the numerator. 6 is the only other side I know in triangle BCU, and that's good. That's okay, because it corresponds with the only side I know in triangle STU, which is, oops, I'm sorry, I didn't want to put the side measure in there. We're not ready for the substitution. We just want to write CU. And it corresponds with TU. Now we'll substitute, because if we set it up using the segments, we can make sure we're right. You're just not going to notice if you make a mistake when you have the numbers. Here we can see BU and CU, they come from triangle BCU. SU and TU, that comes from triangle STU. And BU goes with SU, and CU goes with TU. And that's a lot of U. All right, so we'll substitute now. BU is 12 minus X. SU is 12. CU is 6, and TU is 24. Right? You are allowed to reduce the 6 and the 24. You are allowed to reduce the 12 and the 24. You are not allowed to reduce the 12 and the 12. Right? 12 is not a factor. 12 minus X is the factor. Okay? It's a factor is anything that's added or subtracted together. It's the whole thing. All right? So I actually even have it down here. Also no cross-reducing. So, very important there. Let's put a star around it. Let's underline it. It's at the bottom of the screen. I'm sorry for that. I made sure that I didn't erase it. All right, so no cross-reducing. 6 and 12 cannot be reduced. No canceling in the sum or difference. Do not cancel 12 with 12. 12 minus X cannot cancel with the 12. All right, so, but I am going to reduce. I'm going to reduce the 6 and the 24. That's a good one to reduce. And if that's the only one you reduced, you've made the problem smaller. Because now that's 1 and 4. And you can reduce in the denominator. So if you want, 4 goes into 4 one time. 4 goes into 12 3 times. Right? You've got smaller numbers to work with. Right? It's not wrong if you don't reduce, right? But make sure you don't reduce things you can't reduce, right? That change the value. All right, so now I've got 1. I'm still going to write the 1 just to make sure that I'm multiplying, I'm cross-multiplying. 1 times 12 minus X equals 1 times 3. Boy, these are really small numbers to work with. If you hadn't reduced, you would have had 24 times 12 minus X equals 6 times 12. We'll get the same answer, all right? This is just less smaller numbers. All right, so I don't have to multiply by 1. 12 minus X equals 3. All right, and so now, well, it looks like I took more space last time. So I'm going to get rid of this. I left my steps up here so I could just write underneath them, and I guess I didn't take up much space. Oh, I know why. Because I'm going to rewrite this again. Sorry. That's why I left that there, just so you can see, because sometimes when you're reducing, you lose track of what's left. And I wanted to make sure, since you're watching this tape, that you didn't lose track of what was left. Now I remembered why I wrote that over there. So where I put reduce here, we substituted the values, and then if I reduce, what I have left here is 12 minus X is left, and I have a 3 left. And I have a 1. And I have a 1, right? That's all that's left there. I could have just written the substitute values and in the next step reduce so you can see that really, really clearly. Maybe that's what I should do, but I've already done it, so it's okay. I think you're following along. Hopefully you're following along. All right, so now we'll solve for X. All right, so we multiplied, which wasn't very much, and now we're just going to subtract 12 from both sides. So negative X is equal to negative 9, and if we divide by negative 1, that means that X is 9 is our answer there. And we were actually only asked to solve for the missing segment. Right? If we were asked to solve for one of the sides, we would just plug it in. Right? So that means, and actually let's make sure this makes sense. So what's the length of BU? Well, now we know BU is 12 minus 9, which is 3. And if we look, we've got 3 goes with 12, right? And 3 times 4 is 12. Right? and side 3, BU goes with SU, and BU is 3, and SU is 12, and CU, which is 6, goes with TU, which is 24. And notice that is the same proportion, right? We have 1/4 equals 1/4. So it all checks out very nicely that our sides are now very much in proportion, and we can feel really confident that X is 9. All right, that's the end of this portion of the podcast. All right, thanks for watching. Bye.